Welcome back, trigonometers and pre-calculators. Yes, I do enjoy using those words, even though they're cheesy. So maybe that's why. I don't know. But I am back to talk to you about some more trig identity problems, particularly this time double angle problems and half angle problems. Actually, we're going to start with double angle problems in this video and then progress on into half angle identities in a later video. So what I'm going to show you right now is 3 different problems using double angle formulas. Okay, and here are your double angle formulas. You'll notice that cosine of 2 theta actually has 3 different formulas. And so a lot of times students are like, so how on earth am I supposed to know which one to use? Well, it kind of depends on what you got. And there's really not a wrong answer. There might be a more complicated and a less complicated answer depending on what you're starting with. But really, all 3 of them work. All 3 of them mean the same thing. You can show how this is equal to this, etc. So the choice is usually yours. So let's look at the first problem here. It says use the figure to find the exact value of the trigonometric function. Gives me a triangle, and it says find the cosine of 2 theta. Okay, so looking at the formula for cosine of 2 theta, this is the one that I could use whatever I want. So one of them involves cosine and sine, one of them involves cosine only, one of them involves sine only. I really don't particularly care. It might be easier to use this one or this one so that we only have to find the cosine or only have to find the sine, but it's not like it would be really harder specifically, like much harder, just fractionally harder at best or at most to use this one. Let's go ahead and use the second one. Let's say cosine 2 theta is equal to 2 times the cosine of theta squared minus 1. Now, theta is not squared. The whole cosine of theta is squared. One thing you have to remember is that when we write this, it's a notation thing that what it really means is you're taking the whole cosine of theta and squaring it. The reason we write it this way is because if you were to write the squared at the end, it would look like you're just squaring the angle. So this just means the whole expression cosine of theta squared. Okay, so we're going to do 2 cosine squared theta minus 1. So cosine of 2 theta equals 2 cosine squared of theta minus 1. So in order to do this, I need to know what the cosine squared of theta is, which really means I have to find the cosine first. So cosine Sohcahtoa, remember, our basic right triangle trig, the ca part stands for cosine is equal to the adjacent side over the hypotenuse. Here's the angle I'm working with. The side that's adjacent to that is the 24 right here, and the hypotenuse is the 25. So the cosine of theta for this particular triangle is 24/25. Okay, so this now becomes 2 times 24/25 squared, all minus 1. If we square that, I think it's 576. Let's see. 24 squared. It is. Okay, so this is 2 times 576 over 625, all minus 1. I'm going to go ahead and put everything in terms of fractions with a denominator of 625 because I have to have a common denominator to add or subtract fractions. So this is like 2 over 1, so it's really only going to double my numerator. So let's go ahead and do that. And we get 1152 over 625 minus 625 over 625. And that gives me 527 over 625. And that is my answer. All right. Let's do another one. The next problem we're going to do is a lot like that one. Same directions. Use the figure to find the exact value of the trigonometric function. The big difference is just what we're given. We're given a triangle, so it's not really a big difference, but we're given a triangle with different